Hey everyone, and welcome to this video. In this video, we're going to learn another method to finding limits when we have indeterminate forms. So let's get started. All right, so we're going to look at a couple of these questions real quick. We remember as we were approaching limits back before, we were getting these indeterminate forms, right? And how do we want to approach these problems? Well, all we want to do is take this value 2 and we want to just like plug it in for x, so 2 and 2. So we would get in the numerator we get 2 minus 2, and in my denominator 2 squared minus 2, which is equal to 0 over 0. And then in the second one here we would plug in infinity, right? We'd be looking at end behavior, but really what's happening is in the numerator we're getting negative infinity, and in my denominator I'm getting positive infinity. So it's not really giving us a lot of information. Like, what do we go on? And so right there, we have all those indeterminate forms that we can see. We always see 0 over 0. That's probably the most common one, but we also see a bunch of the infinities over infinities and their combinations, and also 0 times infinity, 0 to 0. All of these are different options, but really we're just going to be focusing here in this class on like this list. This is what you're going to see the most. And I taught y'all before how we're supposed to handle it. When we see indeterminate forms, that means more work. But sometimes that work can be really tedious and really algebraic heavy. So now that we know all these rules of derivatives, and I'm going to introduce a couple short new rules today, but now that we know all these new rules of derivatives, we're going to apply them to determining these limit values. So go ahead and take a look at these examples. All right, so I want to kind of scroll down here and look at these examples, because the ones above, those are pretty easy to solve, right? But these examples right here, they're not as easy. And so if I plug in 0, like how am I supposed to, and I get 0, 0, so I get 0 over 0, or in this one we get positive infinity over infinity. But we can see as x approaches infinity, we have some sort of end behavior happening. And we can see here at 0 for this question, we have this limit approaching a value. So we know that this limit equals 0, but the limit algebraically is not easy to do. That is where this new rule comes in, and that is called L'Hopital's rule. So here's what it says. If we have this limit and the limit of the numerator is equal to 0 and the limit of the denominator is equal to 0, or if we have some sort of infinity combination, then what we can do is actually find that derivative of the numerator and denominator and find that new limit. There's a very specific way you have to write this, and I'm going to be writing that as I go through these first few examples. All right. So in this question, right, we can see like, okay, we might be able to factor this. We might be able to plug in 2. Initially, what you should always try to do is mental arithmetic. Okay, if I plug in 2, what happens? And I get 9. Let's see, that's going to be 3 times 4. That's 12 minus 14. That's negative 2 plus 2. That's 0. And then in my denominator, 2 minus 2 is 0. So I'm getting that indeterminate form. But here is how I want you to show that. I want you to take the limit of the numerator and the denominator. So the limit as x approaches 2 of 3x squared minus 7x plus 2, and we can calculate that. We're plugging in 0 and we're getting 0. And I'm going to also find the limit as x approaches 2 of x minus 2. We can calculate that, plug in 2, 2 minus 2, we're getting 0. All right, so when we get that happening, we can apply L'Hopital's rule. So this shows us, okay, all right, I know that the limit of the numerator and the limit of the denominator equals 0. I have now shown that. I'm not writing equals 0 over 0. I am showing that I can now apply L'Hopital's rule. Okay, so let's go ahead and do that. We're going to take the derivative. So I'm going to write the limit as x approaches 2 of 6x minus 7 over 1 equals, well, now I can just plug in my value for my limit. So that's going to be 6 times 2 minus 7 over 1, which is just trivial. So that's going to be 12 minus 7, which is equal to 5. So this limit, the limit that we were just working with, equals 5, right? So L'Hopital's rule allows us to apply our knowledge of derivatives now to limits, okay? Always, always, always try to plug in first, but let's go ahead and move on to part B here. So the limit as x approaches negative 3. In my numerator, I'm getting 0. and we have to write that out. The limit as x approaches -3, as x approaches -3 of x plus 3 equals 0, and the limit as x approaches -3 of the square root of x squared minus 5 minus 2 is also equal to, let's see, that's 9 minus 5, square root of 4 is 2, 2 minus 2 is 0. Okay, so I am now showing that I can apply L'Hopital's rule here. And so now I'm going to take my derivative. So the limit as x approaches -3, the derivative of the numerator is just 1. And the derivative of the denominator, well, we would have to apply a chain rule. So this is why we introduce this after learning all of our rules, okay? So we're going to have the square root of x squared minus 5. So that's going to be 1/2 times x squared minus 5 to the -1/2 times 2x. That is an application of the chain rule. And now I can plug in the -3. So that's going to be 1 over 2. That is going to be 9 minus 5 to the -1/2. And then 2 times -3. Okay, keep simplifying this. 9 minus 5 is 2. So 4, square root of 4 is 2. The reciprocal of that, so that would all divide out there. So I get 1 over -6. All right, let's see what I can do with this. I'm going to plug in the -3 now. And to make this a little bit easier with the negative exponent, I'm going to write this as square root of -3 squared minus 5 in the numerator, all over, and oh, the 1/2, that 2 is going to go out in front of it as well, all over 2 times -3. All right, so I'll get 2 times 2 over -6, which is 4 over -6, which is -2 over 3. So you can see how applying L'Hopital's rule really goes straight to the answer. Approaching this problem with what we knew of limits before, it was just we had to do algebra. We'd have to multiply by the square root of x squared minus 5 plus 2 over the square root of x squared minus 5 plus 2 and using the conjugate. But now, if you forget that, I always said it was okay because I was going to leave you with this lesson in the future, right? So what we're doing is still finding the exact same thing, but this is applying our knowledge of derivatives to these limit problems that were very algebraic heavy before. All right, let's go ahead and move on to question C here. So the limit as x approaches -2. In this problem, I worked that out beforehand. We're going to end up applying L'Hopital's rule twice. So what ends up happening is if you keep getting indeterminate forms, you can keep applying L'Hopital's rule, right? So if you're getting like 0 over 0, you can, the limit of the numerator is 0 and the limit of the denominator is also 0. Apply L'Hopital's rule again. It is definitely okay. But if you get like 2 over 0, then you're getting a vertical asymptote or something. So you have to keep that in mind. It's only for these indeterminate forms. So let's go ahead and do this. The limit as x approaches -2 of this numerator. So that's going to be x cubed plus x squared minus 8x minus 12 equals 0. And the limit as x approaches -2 of x cubed plus 8x squared plus 20x plus 16 also equals 0. Okay, you can check that if you want. I've worked it out already. I know it comes out to be 0. Don't take any shortcuts here. Write this out. No fractions. Don't do like 0 over 0. Write out these limits exactly like it shows. Now what we're going to do is apply L'Hopital's rule. So the limit as x approaches -2 of 3x squared plus 2x minus 8 over 3x squared plus 16x plus 20. All right, so let's look at what happens off on the side here when I find these limits of the numerator and the denominator. So the limit as x approaches -2 of the numerator, 3x squared plus 2x minus 8. Well, that comes out to be 0. And the limit as x approaches -2 of the denominator, 3x squared plus 16x plus 20, also equals 0. So I'm going to apply L'Hopital's rule again. And this is what it's going to look like. So the limit as x approaches -2 of 6x plus 2, taking the derivative of the numerator, and 6x plus 16x, just 16, taking the derivative of the denominator. All right, now I'm able to plug in -2. So I'm going to get 6 times -2 plus 2 over 6 times -2 plus 16 equals -12 plus 2 is -10 over -12 plus 16 is 4. So that's -5 over 2. Okay. And I want you guys to keep in mind is we're taking the derivative of the numerator and denominator because we're calculating a limit and we are finding a derivative of the numerator and denominator. We are not using a quotient rule. Okay. So keep that in mind. This isn't a quotient rule. This is a limit question. It's not asking us find the derivative. It's asking us to calculate the limit. So just be very clear on that. And now let's move into our last one, the limit as x approaches 1. So let's look at these limits of the numerator and denominator. And if I plug in 1, I get 5 minus 4 minus 1, so I get 0. And in my denominator, the limit as x approaches 1 of my denominator, I also get 0. So now I can apply L'Hopital's rule. So the limit as x approaches 1 of the derivative of the numerator is going to be 20x cubed minus 8x over -1 minus 18x. Okay, now can I plug in 1? Yes, I can. That is going to get 20 minus 8 in my numerator over -1 minus 18, which is going to be -12 over +12 over -19. So it's all negative. So -12 over 19. And so that is what that limit comes out to be, right? And before we couldn't, if you're looking at that first, or if you're looking at question D, what you're noticing is like, okay, this is not a function that I can factor, right? So it's not something that's easy to work with. And in that case, I always want you guys to remember and rely on L'Hopital's rule. And then really important here at the bottom is, you are never going to be, I'm never going to be happy if you guys are going to be writing 0 over 0 or infinity over infinity. It is not equal to. Notice nowhere in my problems did I write equal 0 over 0, infinity over infinity. It is very, very important that you guys do not write that because you will lose points on free response questions if you write that. Okay, it is a very clear no in for the readers who read your exams that they are going to be taking points off if you write that. So please do not do that. In the next video, we're going to finish this lesson, show some more examples as we look at limits as x approaches infinity and things like that. So I'll see you in the next one. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.